NFPA 70E training and certification programs are available through multiple training organizations. The National Fire Protection Association offers the NFPA 70E Electrical Safety in the Workplace course. The certification offered by the NFPA is the NFPA 70E Certified Electrical Safety Compliance Specialist. The International Committee for Electrical Safety provides a comprehensive NFPA 70E training program. The INCOSE certification is the INCOSE Certified Electrical Safety Specialist. The American Society of Safety Professionals offers a 2-day NFPA 70E training class. The ASSP certification is the ASSP Certified Safety Professional with NFPA 70E specialization. The Electrical Training Alliance provides various NFPA 70E training courses. The ETA certification is the ETA Electrical Safety Compliance Specialist. The National Electrical Contractors Association offers an NFPA 70E training and certification program. The NECA certification is the NECA Electrical Safety Manager. To find a training class, firstly, contact the training organization directly to inquire about upcoming classes and schedules. Secondly, check with local electrical contractors or safety consulting firms. Thirdly, search online training platforms for virtual or online courses. The certification process typically involves completing the training course, passing an exam, and adhering to ongoing continuing education requirements. The NFPA 70E standard, titled Standard for Electrical Safety in the Workplace, is a comprehensive set of guidelines developed to protect workers from electrical hazards. It provides requirements for safe work practices, electrical safety-related work practices, and maintenance. NFPA 70E applies to qualified electrical workers and unqualified persons who may be exposed to electrical hazards. Understanding the key concepts of NFPA 70E is crucial for ensuring a safe working environment when dealing with electricity. Firstly, hazard identification and risk assessment must be carried out. This involves identifying potential electrical hazards such as shock, arc flash, and arc blast, and assessing the risks associated with those hazards. Secondly, approach boundaries need to be defined. NFPA 70 defines different approach boundaries, including the limited approach boundary, the restricted approach boundary, and the prohibited approach boundary. These boundaries determine the distance that unqualified and qualified persons can approach exposed energized electrical conductors or circuit parts. Thirdly, qualified persons must be identified. NFPA 70E requires that only qualified persons be allowed to work on or near exposed energized electrical conductors or circuit parts. A qualified person is someone who has the skills and knowledge related to the construction and operation of the electrical equipment and installations and has received safety training to recognize and avoid the hazards involved. Fourthly, personal protective equipment, or PPE, must be used. NFPA 70E requires the use of appropriate PPE to protect workers from electrical hazards. The type of PPE required depends on the voltage level, the potential incident energy, and the type of work being performed. PPE can include arc-rated clothing, gloves, face shields, and safety shoes. Fifthly, safe work practices must be followed. NFPA 70E outlines a variety of safe work practices that must be followed when working on or near exposed energized electrical conductors or circuit parts. These practices include energizing equipment before working on it, using lockout/tagout procedures to prevent accidental energization, and maintaining a safe working distance. Sixthly, training must be provided. NFPA 70E requires that all employees who may be exposed to electrical hazards receive training on the hazards and the safe work practices required to protect themselves. Training must be provided at least every 3 years or when there are changes in the work practices or equipment. Understanding arc flash hazards is crucial. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails or is damaged. It produces intense heat, pressure waves, and high-intensity light and sound. Arc flash can cause serious burns, blindness, hearing loss, and even death. The severity of an arc flash incident depends on the amount of energy released, which is determined by the voltage level, the available fault current, and the duration of the arc. Arc flash hazard analysis is essential. NFPA 70E requires that an arc flash hazard analysis be performed to determine the potential incident energy at each location where workers may be exposed to electrical hazards. The arc flash hazard analysis must take into account the voltage level, the available fault current, the clearing time of the overcurrent protective devices, and the working distance. Arc flash PPE categories must be understood. NFPA 70E defines 4 arc flash PPE categories ranging from 0 to 4. Each category corresponds to a different level of protection based on the potential incident energy. The higher the category, the more protection is required. Arc flash PPE includes arc-rated clothing, gloves, face shields, and safety shoes. Lockout/tagout procedures are vital for electrical safety. Lockout/tagout is a safe work practice that is used to prevent accidental energization of equipment during maintenance or repair. The procedure involves de-energizing the equipment, disconnecting it from its energy source, and applying a lock and tag to the energy isolating device. The lock and tag prevent the equipment from being accidentally energized while work is being performed. Qualified electrical workers are responsible for implementing and following lockout/tagout procedures. The steps for lockout/tagout include firstly, identifying the energy sources. All potential energy sources that could energize the equipment must be identified. This includes electrical, mechanical, hydraulic, pneumatic, and thermal energy sources. Secondly, notifying affected employees is required. All employees who may be affected by the lockout/tagout procedure must be notified before it is implemented. Thirdly, shutting down the equipment is necessary. The equipment must be shut down using normal operating procedures. Fourthly, isolating the energy sources. All energy sources must be isolated by disconnecting them from the equipment. This may involve opening circuit breakers, closing valves, or blocking moving parts. Fifthly, applying lockout/tagout devices. Lockout/tagout devices must be applied to each energy isolating device to prevent it from being accidentally operated. Sixthly, verifying the isolation. The isolation of the energy sources must be verified by testing the equipment to ensure that it is de-energized. Seventhly, performing the work. Once the isolation has been verified, the work can be performed safely. Eighthly, removing lockout/tagout devices. After the work has been completed, the lockout/tagout devices can be removed. Ninthly, notifying affected employees. All affected employees must be notified before the equipment is re-energized. Tenthly, re-energizing the equipment. The equipment can be re-energized using normal operating procedures. NFPA 70E also addresses safety-related work practices. Safety-related work practices are procedures that are used to protect workers from electrical hazards. These practices include using insulated tools, maintaining a safe working distance, and wearing appropriate PPE. Safety-related work practices must be followed at all times when working on or near exposed energized electrical conductors or circuit parts. Firstly, insulated tools must be used. Insulated tools are designed to protect workers from electrical shock. These tools are made of non-conductive materials and are rated for the voltage level of the equipment being worked on. Secondly, maintaining a safe working distance is crucial. A safe working distance must be maintained from exposed energized electrical conductors or circuit parts. The distance depends on the voltage level and the type of work being performed. Thirdly, wearing appropriate PPE is required. Appropriate PPE must be worn to protect workers from electrical hazards. The type of PPE required depends on the voltage level, the potential incident energy, and the type of work being performed. Electrical safety program requirements must be understood. NFPA 70E requires that employers establish and implement an electrical safety program. The program must include policies, procedures, and training to protect workers from electrical hazards. The electrical safety program must be reviewed and updated at least annually. The key elements of an electrical safety program include firstly hazard identification and risk assessment. The electrical safety program must include procedures for identifying potential electrical hazards and assessing the risks associated with those hazards. Secondly, safe work practices. The electrical safety program must include safe work practices that are designed to protect workers from electrical hazards. Thirdly, training. The electrical safety program must include training for all employees who may be exposed to electrical hazards. Fourthly, PPE. The electrical safety program must include requirements for the use of appropriate PPE. Fifthly, lockout/tagout. The electrical safety program must include procedures for lockout/tagout. Sixthly, equipment maintenance. The electrical safety program must include procedures for maintaining electrical equipment in a safe working condition. NFPA 70E also covers specific requirements for different types of electrical equipment and installations. Firstly, switchgear and switchboards have requirements. NFPA 70E includes specific requirements for working on switchgear and switchboards. These requirements include using appropriate PPE, maintaining a safe working distance, and following lockout/tagout procedures. Secondly, transformers have requirements. NFPA 70E includes specific requirements for working on transformers. These requirements include energizing the transformer before working on it, using insulated tools, and wearing appropriate PPE. Thirdly, batteries have requirements. NFPA 70E includes specific requirements for working on batteries. These requirements include wearing appropriate PPE, using insulated tools, and avoiding short circuits. Fourthly, generators have requirements. NFPA 70E includes specific requirements for working on generators. These requirements include energizing the generator before working on it, using insulated tools, and wearing appropriate PPE. NFPA 70E also addresses the use of electrical safety audits. Electrical safety audits are used to assess the effectiveness of an electrical safety program. The audit should be conducted by a qualified person who is familiar with NFPA 70E requirements. The audit should include a review of the electrical safety program, an inspection of the workplace, and interviews with employees. The audit findings should be used to identify areas for improvement and to develop corrective actions. The benefits of NFPA 70E compliance are numerous. Firstly, reduced risk of electrical injuries and fatalities are benefits. NFPA 70E compliance helps to reduce the risk of electrical injuries and fatalities by providing workers with the knowledge and skills they need to work safely around electricity. Secondly, improved safety culture is a benefit. NFPA 70E compliance helps to improve the safety culture in the workplace by promoting a focus on electrical safety. Thirdly, reduced costs associated with electrical accidents are a benefit. NFPA 70E compliance can help to reduce the costs associated with electrical accidents, such as medical expenses, lost productivity, and legal fees. Fourthly, compliance with legal requirements is a benefit. NFPA 70E is recognized by the Occupational Safety and Health Administration, or OSHA, as a consensus standard for electrical safety. Compliance with NFPA 70E can help employers to comply with OSHA regulations. To stay current with NFPA 70E, regular training and updates are essential. NFPA 70E is updated every 3 years to reflect changes in technology and best practices. It is important to stay current with the latest edition of NFPA 70E and to provide regular training to employees on the changes. Subscribing to NFPA publications and attending industry conferences are also good ways to stay informed about NFPA 70E. When it comes to electrical safety, it is important to remember that electricity can be dangerous if not handled properly. By following NFPA 70E requirements and safe work practices, workers can protect themselves from electrical hazards and prevent accidents. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrical safety professional for specific guidance on electrical safety in the workplace. NFPA 70E also has detailed information on arc flash hazard calculations. Performing an accurate arc flash hazard calculation is essential for determining the appropriate level of personal protective equipment needed to protect workers from arc flash hazards. There are several methods available for performing arc flash hazard calculations, including the IEEE 1584 standard and the NFPA 70E Annex D. The IEEE 1584 standard is a widely used method for calculating arc flash incident energy. It takes into account a variety of factors, including the voltage level, the available fault current, the clearing time of the overcurrent protective devices, and the working distance. The NFPA 70E Annex D provides a simplified method for calculating arc flash incident energy. It is based on a table of pre-calculated values that can be used to estimate the incident energy for different types of equipment and installations. Regardless of the method used, it is important to ensure that the arc flash hazard calculation is performed accurately and that the results are used to select the appropriate level of PPE. NFPA 70E also provides guidance on the selection and use of arc-rated clothing. Arc-rated clothing is designed to protect workers from the thermal effects of arc flash. It is made of materials that are resistant to ignition and melting, and it is rated according to its ability to withstand a certain level of incident energy. The selection of arc-rated clothing should be based on the potential incident energy at the location where the work is being performed. NFPA 70E provides guidance on the selection of arc-rated clothing based on the arc flash PPE category. Arc-rated clothing should be worn in layers to provide additional protection. It is important to ensure that the arc-rated clothing is properly fitted and that it is in good condition. In addition to arc-rated clothing, other types of PPE may be required to protect workers from arc flash hazards. This includes gloves, face shields, safety glasses, and hearing protection. The type of PPE required depends on the potential incident energy and the type of work being performed. NFPA 70E provides guidance on the selection and use of PPE for arc flash protection. There are several resources available to help employers comply with NFPA 70E requirements. These resources include NFPA publications, training courses, and consulting services. The NFPA offers a variety of publications related to NFPA 70E, including the NFPA 70E Handbook and the NFPA 70E Training Manual. These publications provide detailed information on the requirements of NFPA 70E and how to comply with them. There are many training courses available on NFPA 70E compliance. These courses can help employers and employees to understand the requirements of NFPA 70E and how to implement safe work practices. Consulting services are available to help employers develop and implement an electrical safety program. Consultants can provide assistance with hazard identification, risk assessment, arc flash hazard calculations, and the selection of PPE. Staying informed on industry best practices can also assist in compliance. In addition to following NFPA 70E requirements, it is important to stay informed about industry best practices for electrical safety. This can be done by attending industry conferences, reading trade publications, and networking with other electrical safety professionals. By staying informed about industry best practices, employers can ensure that their electrical safety program is up to date and effective. Consider specific electrical hazards and mitigation methods. When working with electricity, it is important to be aware of the specific electrical hazards that may be present and to take appropriate measures to mitigate those hazards. Some common electrical hazards include shock, arc flash, arc blast, and electrocution. Shock can occur when a person comes into contact with an energized electrical conductor or circuit part. The severity of the shock depends on the voltage level, the amount of current flowing through the body, and the duration of the contact. Arc flash is a dangerous phenomenon that can occur when electrical equipment fails or is damaged. It produces intense heat, pressure waves, and high-intensity light and sound. Arc flash can cause serious burns, blindness, hearing loss, and even death. Arc blast is a pressure wave that is produced by an arc flash. The pressure wave can cause serious injuries, such as broken bones, internal organ damage, and traumatic brain injury. Electrocution is death caused by electrical shock. Electrocution can occur when a person comes into contact with an energized electrical conductor or circuit part and the current flowing through the body is high enough to cause death. There are several measures that can be taken to mitigate electrical hazards. These measures include energizing equipment before working on it, using lockout/tagout procedures to prevent accidental energization, using insulated tools, maintaining a safe working distance, and wearing appropriate PPE. Effective communication and coordination are vital. Effective communication and coordination are essential for electrical safety. Before starting any electrical work, it is important to communicate with all affected employees and to coordinate the work to ensure that it is performed safely. This includes discussing the potential hazards, the safe work practices that will be followed, and the emergency procedures that will be in place. It is also important to have a clear understanding of who is responsible for each task and to ensure that everyone is properly trained and qualified to perform their assigned tasks. Regular safety meetings and toolbox talks can be used to promote effective communication and coordination. In conclusion, NFPA 70E is a comprehensive standard that provides requirements for electrical safety in the workplace. Compliance with NFPA 70E is essential for protecting workers from electrical hazards and preventing accidents. By following NFPA 70E requirements and safe work practices, employers can create a safe working environment for their employees and reduce the risk of electrical injuries and fatalities.